Astronomers find planet that should not exist. October 1, 2019. Astronomers have discovered a planet that should not exist, giant, similar to Jupiter, in an unexpected location, and is orbiting a small red dwarf star. According to a new study, astronomers find planet that should not exist. This artist's illustration shows the planet GJ3512b, similar to Jupiter, as a cloudy blue world in orbit around a red dwarf star, 31 light-years from Earth. The planet, which is about half the mass of Jupiter, orbits its star at about a third of that between Earth and the Sun. Image credit, Carmine/render area/jbalala/Seagalego. The discovery of such a large planet around such a small star may force astronomers to rethink the way planets form, the researcher said. Red dwarfs are the most common type of star in the universe, constituting more than 70% of the stars in the cosmos. These stars are small and cold, typically about 1/5 of the Sun's mass and up to 50 times darker. Still, as common as red dwarfs are, only about 10% of the 4,000 exoplanets discovered to date orbit these stars. Using the Calar Alto, Sierra Nevada and Montsec astronomical observatories in Spain and the Las Cumbres Observatory in California, the researchers analyzed the red dwarf star GJ3512, located about 31 light-years from Earth. GJ3512 is about 1/8 of the Sun's mass, nearly 1/7 of the Sun's diameter, and less than 1/100th of the Sun's brightness. Unexpectedly, around this red dwarf, scientists discovered a giant gas planet called GJ3512b, whose mass is nearly half that of Jupiter. GJ3512b orbits its star at a distance of about 1/3 of an astronomical unit (AU), the average distance between Earth and the Sun, which is about 150 million kilometers. This gas giant is a much larger planet than previous studies suggested it could orbit such a small star. For comparison, while the Sun is about 1,050 times the mass of Jupiter, the star GJ3512 is only about 250 times the mass of the planet GJ3512b, said lead study author Juan Carlos Morales, an astrophysicist at the Space Science Institute, Barcelona, Spain. Morales told Space.com: "Exoplanet statistics found so far seem to indicate that low-mass stars usually host small planets like Earth or mini-Neptune. The most accepted model of planet formation, the central accretion model, also points in this direction. But here, we demonstrate the opposite, that is, we find a giant gas planet orbiting a very low-mass star." Scientists also found evidence of another potential world around GJ3512, a planet with the mass of Neptune, which they estimated to be more than 1/6 of Jupiter's mass. They have suggested that this planet orbits at a distance greater than 1.2 AU, but remain uncertain if this world really exists. In addition, the researchers suggested that another massive planet could have orbited GJ3512. GJ3512b's elongated oval orbit around the red dwarf suggests that the gas giant has already entered a gravitational tug-of-war with another immense world that was later launched out of the system, throwing it into interstellar space. Until now, astronomers thought that the central accretion model could explain the formation of Jupiter and Saturn, as well as many other gas giants discovered around distant stars. This model assumes that giant planets are born in two phases. First, rock and ice cores, 10 to 15 times the Earth's mass within the protoplanetary disk of gas and dust surrounding the newborn stars. Then, upon reaching a critical mass, these nuclei quickly accumulate large amounts of hydrogen and helium gas. Low-mass stars, such as red dwarfs, should have proportionally low-mass protoplanetary disks. Therefore, there is probably less material on these disks to form gas giants. In this case, the central accretion model cannot explain the giant size of the GJ3512b, said Morales and his colleagues. Instead, the researchers suggested that the so-called planet-forming disk instability model may help explain the GJ3512b. This model assumes that an unstable protoplanetary disk can fragment into pieces of gas and dust, which can collapse directly under their own gravity to form some, or perhaps all, gas giants, ignoring the need for a solid core to act as a seed. Morales said, "For the first time, we accurately characterize an exoplanet that cannot be explained by the central accretion formation model. This exoplanet proves that the gravitational instability model can play a role in the formation of giant planets. Researchers continue to monitor the system to learn more about its potential second world and perhaps even more planets, Morale said. In addition, they are examining another 300 red dwarfs for more exoplanets, he added.